So, objectives today. We've got quite a few to get through. It's not a lot of hard work. If you have problems with the factoring, then you're going to have a problem today. Okay, because what we're going to do today is not that difficult. I'll walk you through that. But please, if you are struggling with the factoring, you need to come back and see me on that so I can help you out. Okay? If the trial and error doesn't work for you, then we've got the whole, what's it called, the Xbox method or something? I can show you that method. Jessica. All right, so do you guys have your objectives down? Can I change the slide?
Give me a second.
I'll just drink some water.
Oh my gosh. My eyebrow itches.
I don't even know why I asked. He's always gone.
Can you close your laptop, please, Robinson? Grab some paper for some notes. Thank you very
Can I
much.
take my notes online?
No, you don't have math pipe.
Work.
Very good. Who's still writing? Can I change the slide? You're still going. You're good. Sean Lee, they'll come back one by one, okay? As I go through the slide. You got the first one? All right, cool. So let's do the first one. Define a rational expression. So, rational expression is pretty much a fancy way of saying fraction. Yeah, I know y'all got scared already because I said the F word. But that's really what it is. Rational expressions. So in this case, x over y, negative 4 over a, n plus 4 over n plus 2. You've got this polynomial. And it might get kind of weird for you sometimes because they're saying this is also a rational expression. And obviously it is because I can put that over 1, and now it's a fraction. Okay? So everyone okay with what a rational expression is? It's just a fraction. All right, cool. Next objective. Define rational functions and describe their domains. So we're going to just define the domains for now. Obviously, we've already seen what type of what a rational function is. Here is, very important thing to know. Of course, you're going to have some polynomial over another polynomial. But what's important to note, did I say that weird? It sounded weird. Okay.
Yeah.
Very important thing to know, though, is that your denominator cannot be 0. What happens if the denominator is 0? Oh, nothing?
You said nothing happens.
No, I asked what happens.
I don't know.
Yeah, if you have 0 in the denominator, the function becomes undefined. You're making me worry there, AK.
Why?
Yes, I can. So again, the important thing here is 0 cannot be your denominator. You got 0 down there, you are undefined.
Define me then.
How
Sorry.
do I? It's not that there is no solution, it's that there's way too many for us to pick one. So math needs to get together and decide what it would be before it can be defined. But there's so many arguments for different solutions, so we say it's just undefined. We can't agree to something. We won't get into that detail because we got plenty to worry about, right? Right. Can I change the slide? Just an FYI, if you guys want these slides, they're all inside of your math lab. If you go to the, what's it called? The math lab? No.
Not mad.
Let me see here. The multimedia library. Ooh, excuse me. If you go to the multimedia library, you'll see that there's a place for you to select the PowerPoints in there, Jessica. And then you can download those.
Wait,
Thank you.
Is that equation a rational function?
This is a rational function. It's just in very general terms. You got some polynomial over another polynomial. I wish I was sitting over there with you guys. You guys are having a great time. I love it. It's all about happiness. Life is too short. I can change it now? All right, cool. So, here's an example. Take a look at this piece over here. If this was my function, the denominator can't be 0, right? So that means that x, in that case, cannot be what number? 5. because in 5 minus 5 would make 0, making the denominator 0, therefore, so if I'm talking about the domain, in this case, domain can be any x except it cannot equal positive 5. So here's the notation for that. X can be anything except for 5, because that would just break it. That would just break it. So just simple notation, not get too caught up with it.
That's the ending result of the problem.
What's up?
That's the ending result of the problem. Just like that.
Oh, now, this is the domain. All they're saying is, you know what? You can pick any x you want. Like, pick something that's just not 5.
5. I mean, Lord. Man, you said it, so it's the one thing that I wanted to say. You told me not to do it, so I had to.
You get-
4. I get it now.
Any questions on the notation there? See those thumbs up if you're good, down if you're not.
Wait.
I can do the domain. I can read it. No. So this is what this part is saying. On x, you can be any x you want. This bar really means pretty much except. Except you can't pick 5. Okay. So whatever you want except for 5, because then it just breaks it. All right. Can we get to business now?
Yeah.
Anybody else still copying any of that? You're good? All right, cool. So, here's 2 examples. As I look at A, let's see here. I'm not worried about the top because I can have 0 on top, but I can't have it in the denominator. It's kind of hard to see what x I could put in there. But if I factor it, what is this here? 2 and 3. This would be negative, this would be positive, right? Everyone okay with that? So we're bringing in what we did before. Here's what I know. X cannot be negative 2, and it cannot be positive 3. Those are the 2 numbers that would make this denominator 0. Questions there? And what I used was the 0 product property, right? If this is 0, then 0 times whatever number would be 0, and vice versa. It was easier to do it when I factor it. What about the other one? What can x not be?
5 or
Negative
negative 5.
5? Let's see here. 3 minus 10 over 5 would give me negative 7/5. Well, that's okay. I got something out. Nothing wrong with negative 5.
Oh,
Nothing wrong with negative 5. What can x not be in this problem? We'll stop and think for a second. What am I worried about? Making the denominator 0. Is there any way I can turn that 5 into something else? No, there isn't. No, there isn't. There's no variables down there. So the denominator will always be how much? 5. Make sense? So denominator, anything you want it to be.
Wait, so this thing that has to be negative?
Yeah. So these are the 2 that you're okay how I got them, right? So let's check this out. I'm saying that these 2 cannot be in here. So let's do the denominator real quick here. I want to test one of them just to show you what happens. So let's pick 3 because it's positive. So 3 squared minus 3 minus 6. What's 3 squared? 9. And that's 9, right? What's 9 minus 9? 0. So if I pick 3, this would break it. I can't be 3. So technically cannot. Same thing happens with the negative 2. If I plug in the negative 2, I would get the same result and not good. So I shouldn't have said equal. I should technically say should not be equal to. Good.
I get it now that you put the line.
Cool. Yeah. Technically it should be not equal to those. I see what you're saying. That was a really good point.
So,
I overlooked that totally. So what? Carry on? Alright. The next thing we need to do is to simplify them. Put them in lowest terms. I would show you those 2 slides, but they're kind of blah. I'll just get to it. Sounds good?
Yeah.
Okay. What's the matter?
you have homework.
Yeah. How's it not fair?
We literally have 2 days homework. You guys complain when we have like 5 days to do it.
I don't understand what
You know what? I could give you no homework and they'll complain like, why didn't you give us homework? Now I'm not ready for the test.
Test?
test.
Bruh.
The test tomorrow.
Wait, is there actually?
No, I just wanted to see Jessica's expression. It was worth it, Jessica.
I was gonna be sick tomorrow.
Hold on, that's not my laugh. Why am I laughing like that? Is that how I was laughing last week?
Yeah.
I'll tell you later where I got that laugh from. Stupid. Here's what I'm going to do. I'm going to factor the top and the bottom. So, I'm going to start with the numerator. I should have y, right? Two numbers that multiply to 3 and combine to 2. It would probably be 3 and 1, right? Where this is positive and this is negative. You guys see that? Okay, so now I'm looking at the denominator. I'm going to factor the denominator. I'm going to go ahead and try this real quick. Y. Two numbers that multiply to 2 but will combine to 3. A 2 and a 1, right? So I've got a 2 and a 1, and they're both going to be negative in this case. Right? Now, question. What's 1 over 1? What's 2 over 2?
1.
It used to be. It's 1, right? 3 over 3 is?
1.
X over X.
X. Nah, that's a letter. You tripping now.
X over X is 1. Because remember, X can be whatever you want it to be, right?
So
But-
2 letters make a number?
Yeah.
Just doing that now?
Yes, we can. Here, let's do this. Regardless of, so let me just see if this makes sense. Okay? We know that X is a number, correct? Like,
Sorry.
you gotta help me out here.
Okay, keep going.
X over X is equal to 1. This is why. X represents a number, doesn't it? Now, if I have them in one equation, then it has to be the same number. So if X was 5, then I'm looking at 5 over 5, which is,
Oh my god, my head is like hurting.
wait a minute, you know?
No, I don't know what's happening.
All right, let's just define it like this. Anything over itself is 1. And that should make sense to you. That means that when I go over here, now these are all being multiplied, right? So this is something over itself. This is a 1, isn't it? Please don't say cancels out, because it doesn't cancel out. It becomes a 1. Now, if I'm going to say cancel out, I'll probably do this. Cancels out. But that's not true. We know that, right? Anything over itself is 1. And 1 times these guys would just be those guys, right? So I've simplified this. This simply becomes y plus 3 over y minus 2. Okay? Now, while we're here, let's talk about the domain. Domain. X can be anything except for... Can someone tell me what X cannot be? Not X. This is wrong.
Oh, this is hurting my head.
This is wrong. It's Y. What can't it be? Why negative 3? What are we worried about? What becoming 0? The denominator being 0, right? So what can Y not be? 2 and what else? No, that's okay. I can have 0 up there. Right? So negative 3 plus 3, 0. 0 over something is still just 0. That's not undefined. I want you to stop and think about this further, because here is where I lose a lot of people, and this is where a lot of people lose their points on your tests. Is the red the original problem I started with?
No.
It was the top piece, wasn't it?
Yep.
So if I go from the top piece, isn't this its denominator originally?
Yes.
So what else should go here? Someone just said it. 1. It cannot be 1 either.
Shara.
Good job, Shara. It can't be 1 either.
Looks like a bad parenthesis.
It does.
I see Shara with
Is it 1 enough?
Why is there a parenthesis at all though?
It shouldn't be a parenthesis. It should be a...
That's kind of awesome. There was supposed to be.
Not supposed to be. It's supposed to be a... Yeah. Questions on why 1 isn't part of the... It's not part of the domain. Give me a thumbs up if you understand why 1's in there. I wasn't using my phone. All right, let's move on. All right, you guys try this. You guys try this. Hey there. Thank you. Ari. All Ari had some free Tangerine. You better go look for that on Amazon. Get a used copy.
No, I still have it. I'm just lazy.
Huh?
I have it. I'm just lazy.
Oh. Or like me, where you like, anybody reads so slow, it's just like, you can't get it within that time they give you. You gotta go back and renew it. I'm glad it's not just me. Thanks, dude. Thanks for having my back. All right, cool. Nice job. Let's move on.
Wait a second there.
You can't do anything with that.
Oh.
Thanks
Right?
for letting us know it.
Let me think about it.
I did. That's why I gave you plenty of time to think about it.
Go on, moving on.
The denominator is a sum of squares. You can't factor that, right? You would get imaginary numbers. Now, if it was a difference, that's a different, story altogether. But because it's the sum, can't do anything with it. All right, this one can. So I'll have you guys try this one out real quick. You might have to dig out some of those factoring formulas.
P squared.
Oh, excuse me.
Say something.
Yaakov. Isn't that from Aladdin?
Mr. Munoz.
What? No.
Because it's PP. Whatever.
Ah.
It's probably right. You probably just don't like it because
No, I know what you tried to do. I know what you tried to do, and no. Have a great day and welcome.
Are you just looking at each other? Mr. Munoz, you realize it's recording? We're waiting for you.
What happened? It's three?
Like 3 stories of it.
Oh, they didn't even give me wallets. They're free. I didn't even get all mad about it. All right. I see you all have the answers already. So, thanks for volunteering, Jessica. What'd you get? Wow. Oh, that's not your answer?
That was your answer.
Okay. It's 1 times something, so yeah, you're almost there.
1 times 4.
The numerator is going to factor like this, guys. And if you are wondering why, please let me know, and I will tell you. Okay? So, here's the one that Jessica was talking about. 1 plus P over 1 plus P is 1. Okay, what was your question back there?
Why did you do the 1 plus P squared?
Because this
1 plus
is the sum of 2 cubes. It's 1 cubed plus P cubed. And I told you, well, that's ugly. That looks like a cube. If you can write it in this form, then you should have that formula. First plus second, first one squared minus first. Oh, should that be a minus? My bad. That should be a minus.
I got you.
Someone double check my formula, see if it's right. Second plus second one squared.
You're good.
It's minus, right?
Yeah.
Okay. If you don't have this formula, then you want to make sure that you do have it.
I'll have it right now.
Right now? You just scribble a little happy face and like, I got it. Shane, you're so bad. Setting them up for failure.
That one.
Okay, how am I getting this done?
Shane, I'm gonna take my ACT. What do I need to bring? Skittles? 2 packs. Bring an abacus. Horrible, horrible, horrible.
I always say that.
Yes? It's the first one plus the second one. So this is the first term. That would be the second term. And I think the book formula was like x plus y, right? X plus y times squared minus xy plus y squared. Yeah. That was a nice way out of it, dude. I like the way you did that. I was confirming with him the formula, and he just kind of looked away and asked me a question. It probably wasn't even important, was it?
Why are you laughing?
Take the p hat. Oh, yeah, that's a good one too. That'll work. Nobody likes to take the p hat.
Wait.
So wait, did it equal 0?
No, this. 1 minus p plus p squared.
How is that the denominator?
No, that's the numerator. The denominator made 1 with with this piece.
Oh, it made 1.
Yeah.
So wait, can you write it in the...
Parentheses? I would leave it that way. Actually, I would start, like if they don't have parentheses, I would start by writing them in. Yeah. Yeah. Just leave it like that. I don't know if I understand the question.
It's okay.
I'll come over here and you can ask me later, okay? DJ, you okay? Oh man, me too. I need a foot rub. I need a petty. I need a mani-pedi. So, she's gone. Here's what I need to caution you guys on. See if I can use my farm shit pen here.
I want some McDonald's apple pie.
Can you guys see this right here? You should, because I made it real big. You cannot do this. You cannot say, oh, 2 over 2 is 1. That's gone. I've got y. Because this, let me close this. Because the numerator is an item. You want to make sure that you keep it together. Okay? So you don't know what that is until you know what x is. So it could be that the numerator is 12, right? Let's say x was 10. Sorry, not 10. If it was 14, 14 minus 2 would be 12. You can't cancel 12 with a 2. It wouldn't make sense. Now, same thing over here. They said, oh, the 2 over 2 is a 1, so it's going to give me y minus 1. You can't cancel things like that. That's why I was telling everybody, or a minute ago, when you have a problem, start by putting parentheses around all the binomials. That way you don't try to separate them into pieces. Okay? It goes together. All right, let's move on. Like here. Oh, this is a good one. Can you guys see that these are almost the same?
Yeah.
Except they're kind of swapped? I'm just going to give you guys a shortcut here. We like shortcuts? If they were the same, it would equal how much? 1. But because they're swapped here, this actually equals negative 1. Oh, I'm still using I'm using my magic marker. That would equal negative 1. Yes? Oh, I thought you were asking me why.
Oh, why, Mr. Munoz?
Yeah, for real, like why?
Why?
Yeah, I wanna know.
Okay, so let's do this then. Why is it negative 1? This is why. R minus 1. Let's fix these. Let's put them in order. That means you've got negative R plus 1, don't you?
Yeah.
Obviously, they're not the same.
Yeah.
But I could factor out a negative here.
Yep.
And this is why I don't like recording. So I factor out a negative 1 in the denominator. I'm going to get R minus 1 now. And now I have them the same. See that?
Yes.
So 1 over negative 1 is?
Negative 1.
Negative 1. Standing. Oh, thank you. So watch for those things. Watch for those things. They're nice little shortcuts you can take.
Thank you.
What issue? Oh, I thought you said issue. I'm sorry. I like what issue? I can help you. There was another one that sounded like they were playing football. They're like, hut two, hut two. All right, try this. You should try this. I'm not saying this is going to be on the test or anything,
I tried it. It doesn't work.
but it's going to be on the test.
You know, we're mathematicians are really good about it. 1 second.
Oh my. You guys done?
Yes.
I said no. I did. I actually made house.
Are you guys taking notes?
Why don't you start by writing other? Oh! Back to the bottom.
Oh yeah, it's been there.
Thank you. Please. Please be careful with the how you factor that denominator. The number is first in this case, so you want to make sure you have the numbers first. So it should be 2 plus minus. Remember the conjugates? Okay. Now, which of these two are similar to the top? The 2 minus p, right? They're just backwards. So this and this make -1. Good. So now you can clean it up. -1 over 2 plus p. Okay, look for those shortcuts. Stump the math wizard. Okay, what's questions? All of them, because I don't make mistakes, so.
Man, shut.
Nice. Shut your mouth. Thank you.
Do you want this one to trade it, or am I borrowing it?
Thank you. Thank you. Shh. Thank you. Thank you. Marcellus. Marcellus, there's 2 of them. Okay. Next objective, we're going to multiply. Multiply.
That's what she said.
If you want to just watch me do this first, I'll let you copy after. That way you see what I'm doing. Jessica, it can get complicated because they got C's in here, and my C's will start looking like parentheses. So please watch what I'm doing, and I'll tell you exactly how I do them. I start upper left-hand corner, always. I can see that they have a C in common, So I'm factoring that out. That's going to leave me with c plus 2. I know, right? Questions there? In the denominator, that's the difference of squares. So I'm going to get conjugates. C plus 2, C minus 2. Going over to the other numerator now. That's a perfect square, isn't it? Okay? So that's going to give me C, oh, I got myself. C minus 2, C minus 2. And I could write it as square, but I want to see all of them. Okay? And in the bottom, I can factor out a C. That will leave me with C minus 1. At this point, I'm looking for ones. I'm looking for ones. Anything over itself, right? So here's a 1. This and this make a 1. This and this make a 1. Anything else?
No.
So that means that I've got C minus 2 over C minus 1.
Well, then why don't you just stick the C's right there? Oh, you meant well, you have 2 C's on the bottom still.
Okay. Questions?
I just told you.
You just told me?
Asked you.
What can X not be? It cannot be. Can't be 1. 1 because of this guy. What else? Cannot be 2 because of this guy. Cannot be 3's okay. C over C is 1. Negative 2?
No, but then it would only be. Do you know what I'm saying too?
What else?
There would only.
Where would negative 1 be a problem? Just look at the denominators. It can't be C. Yeah. I know you're looking at C, right? Because this is the negative 2. And you're looking at that. What can that not be? 0. Because if that's 0, then 0 times that number is 0, times that is all 0. So you can't be those 4. Good job, whoever said 0. Now, I want to answer your question. Fine. Fine, answer it. Whoa. What's your question now?
Shit, well, you moved them, so never mind.
Watch your words, please. Okay, what's your question?
Alright, so on the bottom you have 2 C's on different sides. 3.
Where, up here or here?
The left bottom side.
There's, yes.
There's 2 that are not crossed out.
No, when I cross this out, the whole thing goes away.
Um,
Yes, this is all one number.
okay, never mind.
That's all just a number.
I know, I get it. I said never mind.
Okay.
Yeah. I know.
We're good? DJ? Marcel? Question, go ahead. Shay.
Wait, so the C,
Sorry, Shay.
the C on the top, that's like outside the parentheses. did it
This
cancel-
one?
Yeah, did it cancel out the other one?
With this one.
Yeah.
Yeah.
Okay.
It made it 1. Good? Robinson? Robinson? Pray at home or at church? Anything else? Move on? Whoa, where'd it go? Okay. Can I just do this one for you guys real quick? Or do you guys want to try it?
Is this the last one?
It's like the last one. Go ahead, you try. You try
No,
this
you
one.
can.
I can, but the point is that you can
But
do
you
it.
said this last one.
No, there's more. I'll do one more after this, okay? And then we'll call it done.
Sorry, no, I feel bad.
Don't forget to. You've been thinking about it? It's been haunting me. Here, I'm gonna look for it here while I do it. done, Angelina? Ready to come do it up here?
Yeah?
Come on.
I mean, if you insist.
I do insist. Oh, San Diego. You can do it.
I know. So basically, good as.
Basically. Basically, yeah. What happened?
Don't worry, I'm doing it. Huh? So is it this? And a minus 2, right? Would it do that?
Not a 2 though.
Oh, no.
See what?
8?
No, we can wait.
What is equal to 8? 4? Where do you get the 4 from?
Square root of 16.
Square root of 16 is. Oh. Okay. I got it now.
Nah, those are probably gross. Actually, yeah, no, that's gonna be gross. That's so gross.
Oh, pimple right here. That's all I got.
Good. Good job. So,
Thank you.
the bottom is not going to change. That's just a 1, not a big deal. And then we got n plus 4, right? So, here's the breakdown. All we got to do now, Jessica, is find some. What are we going to find here? What are we looking for? Ones. We're looking for ones. The n plus 4, n plus 4. Anything else? That's it. So, m minus 4 over m plus 2. Well, what's 1 times a number? That number, right? Yeah. Did I break your heart? You just broke my heart. Is your arm sleepy? Okay. You make me nervous, dude. Okay. Questions here? Can I change this? I want to do one more. Thank you. Okay, last one. Wait a minute, let's see which one here. I'll do this one. Okay. This is the last objective. These are dividing them. Now, just real quick before you get all crazy about dividing them, do we really divide fractions by fractions?
No.
You multiply by
You multiply fraction by
the reciprocal, right? So, I'm going to have 5p plus 2.
Change the sign if we did that?
Yeah, over 6. That division is going to become a multiply, and I'm going to write it backwards. So now I have this. And you always flip the right. Please never flip the left. You flip the left, you're wrong. You just lost points.
What do you mean flip the left?
See how the left side of, the right side of the division? That's what you want to flip. That's where you want to take the reciprocal of. Yeah, the left side, you never flip it. Okay? Now at this point, same as before, right? Yeah, change the sign from divide to multiply, but that's it. Now this factors into 5p plus 2. No, not negatives. Just change.
If you flip it, it was a negative.
No, you change the signs, I said. From divide to multiply. That's it. No, not that. That does not. That don't do it. Okay? So, I factored here, Robinson, the red part. I'm a magnet, aren't I? I'm going to wait. I can make you. Jessica. Jessica. I'm going to stand up for myself. I factor out the common factor here, lower left. Guys, I'm almost done. I said, guys, not AK. 5 plus 2, 5 plus 2 are going to make 1. You're going to end up with 5 over, what is that, 18?
Yeah.
That's it. All right, I'm done. 5 times 3, 6 times 3 is 18, right?
Yeah.
And
Okay.
bye, Seth. Have a good day.
Ew.
Let's see if you watch this, right? Did I start it again?